Okay, so first let's just ask kind of, this is one of the things I do in the book, and just ask like, what do the Gaussian integers even look like? Maybe this will be a good question for you. If you were going to draw all of the Gaussian integers, if I said to you, you cannot have dessert until you draw all the Gaussian integers, what would you do?
Well, they're infinite.
Okay, so when would you have dessert?
Never.
Oh wow, I better not say that then. Can you draw some of the Gaussian integers?
Yeah.
What do you think they look like? What is the geometry of the Gaussian integers? Actually, first start by just drawing the regular integers. And then tell me what you...
Just like the number?
You don't have to write down which number they are, but draw them and what they look like on the line here. What do the integers look like?
Oh, they just have forms of 1.
Yeah, so mark them out on the line. Mark out the points where the integers are on this line. You still okay?
Yeah. The family math is out of school now.
And this.
All right, and how would you describe what you see here with the pattern of the integers?
Well, they're all kind of evenly spaced. You have a distance of 1 to go right and -1 to go left.
Okay. And how would you describe what the irregular old integers look like?
So I'd say that they're all, I guess, they're on the line. I don't know if the concept of lines like this still works, but they're on the line I equals 0.
Okay.
They're not a complete line.
All right. So why don't you draw in the Gaussian integers now and tell me what you think? You don't have to draw all of them. You can draw some of them.
Well, sort of around this center area. They're kind of like in this entire plane.
Okay. And so how would you describe what this looks like? What if you drew them all in? What would the Gaussian integers look like?
They just look like a grid.
Looks like a grid. Okay. What would you say?
I'd say the Gaussian integers are the lattice points of this plane.
Okay. Fascinating. Okay. So they look different. They look different. And now you had mentioned the integers are closed under addition. So let's see, 1, 2, 3, 4. So this is the point 4. And let's say this is the point 1. And what happens when you do 4 plus 1?
You just get to 5.
You get to 5. But what about something like this? 1 plus 2i and pick another point. Anyone you want.
3 plus I.
3 plus I. Okay.
It's right there.
What happens when I add these?
Well, you get 4 plus 3i.
Okay. Do you think where will that be actually?
So 1, 2, 3, 4, and then 2, 3.
All right. So why don't we highlight the points? Make them like darker green or something, or bigger dots. The ones we picked. 1 plus I, and then 4 plus 3i is this thing. So how would you describe just the algebra of what you did to sum?
Well, we added the integer and the I parts.
Okay.
So it's it can go up and down too, not left to right.
Okay, but we also saw that there's an interesting geometric description. Can you describe any geometry you see with adding the numbers here?
This is, I'm not sure, but kind of looks like an equilateral triangle.
Oh, do you think it would always be an equilateral triangle?
I don't think so.
Okay.
So,
Maybe not. Maybe this was an equilateral triangle. I'm not sure. I didn't want to do the computations, but maybe. Do you see any geometry here?
You might be adding the lengths, like these distances, together. I'm not sure.
Okay. Ooh, interesting.
Because we got, I'm gonna check this. So the distance from here to the origin is 5.
Oh, okay.
To 3, 4, 5.
Uh-huh.
And then the distance from here to the origin is root 5. And then the distance from here is root 10.
Okay. So did we add the distances?
We did not.
We did not add the distances. But did we make any geometry here? Do you see anything interesting in the geometry on the board?
maybe a little bit like a parallelogram.
Does look like there's a parallelogram there. Where is the parallelogram?
Kind of looks.
So maybe there's a parallelogram hiding with addition. Pretty neat. But you're right, we did not add the distances. That was a good thing to check. We didn't add the distances, but it does look like there's a parallelogram there. Let's talk about multiplication.
All right.
Alright.